Hello students, welcome to CREATA classes. I am Gurmeet Singh and also welcome to our series on areas related to circles. In this series, we will cover all these lectures using the power of animation and the visualization. The link to all the lectures are given in the description. Check it out. Apart from all this lecture, we are also having the formula list and the quizzes. The PDF of the formula and the concept list will help you to brush up the concept, and the quizzes will help you to check your preparation, the level of preparation before the exam. Check the link in the description. In this lecture, we will cover exercise 11.1, question number 6 to question number 10. So without taking any further time, let's start with this lecture. Here it is. Let's take question number 6. A chord of circle of radius 15 cm subtends an angle of 60 degree at the center. Find the areas of the corresponding minor and major segment of the circle. In this question, a circle of radius 15 cm is given and also a chord is given which is subtending an angle of 60 degree at the center, and we have to find the area of the minor and the major segments of the circle. So we are having the chord AB. This portion is the minor segment. Segment is the region between the chord and the arc. This is minor segment and this is the major segment. So what philosophy we use to find the area of the segment? The area of the segment is area of the sector minus area of the triangle. Firstly, we will find the area of the sector. Then we will find the area of the triangle. So firstly, let's find the area of the complete sector. So this is the formula of area of the sector. The input are radius and the theta. Radius, it is given in the question as 15 cm and theta is also given as 60 degree. Let's put the value into the formula. On solving, we got area of the sector as 117.75 cm square. We got the area of the sector. Let's proceed with the area of the triangle. Here this is a triangle. The angle is 60 degree and the two sides of the triangle are 15 cm. A concept that you should know which will be applicable in the future similar type of questions. Whenever you are having a similar case in which this angle is 60 degree and these are the two radius, means these two sides are equal to each other, that triangle is an equilateral triangle. I will show you how. In the previous lecture also we are having a similar type of case. Here this angle is 60 degree and these two sides are 15 centimeter. And we know the property of a triangle, that is the angles opposite to the equal sides are equal to each other. It means these two angles will be equal to each other. For the time being, let's assume both the angle as angle x, both are equal. And we also know the sum property of a triangle, that is the sum of three angles of a triangle is equal to 180 degree. So 60 degree plus angle x is equal to 180 degree. On solving, we got angle x as 60 degree. It means all the three angles of a triangle are equal to 60 degree. That is an equilateral triangle. So whenever you are having the similar type of case in which the chord is subtending angle of 60 degree at the center, it means that triangle is an equilateral triangle. All the three sides of a equilateral triangles are equal to each other. And we know the formula of area of a equilateral triangle, that is root 3 by 4 a square, where a is the side of the equilateral triangle. All the three sides of the triangle are equal, so a is equal to 15 centimeter. So let's use the formula. Let's put a as 15. We got area of the triangle as 97.31 centimeter square. We got the area of the sector. We also got the area of the triangle. Now we can find the area of the minor segment, which is equal to area of the sector minus area of the triangle. Let's put the value. We got the answer as 20.43 centimeter square. So one part we have done, that is we got the area of the minor segment. Let's find the area of the major segment. This is the major segment. Can we say area of the major segment is equal to area of the complete circle minus area of the minor segment? Yes, we can say so. Once we remove the area of the minor segment from the complete area of the circle, we got area of the major segment. And area of the circle, it is pi r square, the radius is 15 centimeter. And area of the minor segment we have just calculated as 20.43. On solving, we got area of the major segment as 686.06 centimeter square. That is the answer of question number 6. So we have done with question number 6. Let's move to question number 7. A chord of a circle of radius 12 cm subtends an angle of 120 degree at the center. Find the area of the corresponding segment of the circle. In this question, we are having a circle with radius of 12 cm, and this circle is also having a chord which is subtending an angle of 120 degree at the center. Here OA and OB are the radius which are equal to 12 cm. We have to find the area of the corresponding segment of the circle. Here this is a chord, so this is the segment whose area we have to calculate. The same philosophy we have used in the question number 6, the same philosophy we will use in this question. Area of the segment is equal to area of the sector minus area of the triangle. Firstly, we will find the area of the sector, then we will find the area of the triangle. So let's find the area of the complete sector. The formula applicable is theta upon 360 into pi r square. The input are theta and the radius. Theta, it is given in the question as 120 degree and radius is given as 12 centimeter. Directly put the value into the formula. We got area of the sector as 150.72 centimeter square. Now the question is how to find the area of the triangle. So let's proceed. We will use the same concept that we have discussed in the theory part. We will draw a perpendicular from the point O towards the chord AB. We got OD which is perpendicular to AB. And we know the property of a chord and a circle, that is OD is the perpendicular bisector of AB. And OD is also the angle bisector of angle O. That is OD is dividing the angle O into two equal parts. The complete angle is 120 degree, so these two angles will comes out to be 60 degree. I am not going detail into the concept, but you can prove both the triangles as congruent to each other, as all the three sides are equal. Through congruency, you can prove the corresponding angles are equal to each other. So these two angles are equal to each other. So we got both of these angles as equal to 60 degree. Let's take the triangle ODB, this triangle. This triangle is a right angle triangle. This angle is 60, this angle is 90. So this angle will come out to be 180 degree minus 60 minus 90, that is 30 degree. We have simply used the sum property of the triangle, that is the sum of three angles of a triangle is equal to 180 degree. Two angles we know, the third angle we can easily calculate as 30 degree. Now we will find the two sides of the triangle. One side, that is hypotenuse, is given as 12 centimeter. We will find OD and DB through trigonometry. Here OD is the perpendicular and DB is the base, and angle 30 degree is the trigonometric angle. The side opposite to the trigonometry angle is the perpendicular, and the side opposite to 90 degree angle is the hypotenuse, and the remaining side DB is the base. The same concept we have covered in the trigonometry chapter. Let's move further. Firstly, use sine theta. Sine theta is perpendicular over hypotenuse. Here perpendicular is OD and hypotenuse is OB. And theta is 30 degree and OB is 12 centimeter. Sine 30 degree is 1 by 2. Let's put the value. On solving, we got OD as 6 centimeter. Further, let's use cos theta. Cos theta is base over hypotenuse. Here base is DB and hypotenuse is OB. Hypotenuse is 12 centimeter and angle theta is 30 degree. Let's put it into the formula. Cos 30 degree is root 3 by 2. On solving, we got DB as 6 root 3 centimeter. So for this triangle, we got OD as 6 centimeter and DB as 6 root 3. Further, we have seen that OD is perpendicular bisector of AB. It means D is the midpoint of the complete chord AB. D is the midpoint of AB. That is AD and DB are equal to each other. These two line segments are equal. So AD will also be equal to 6 root 3. So AB will be equal to AD plus DB. That is 6 root 3 plus 6 root 3, which is 12 root 3 centimeter. The length of the chord AB we got as 12 root 3 centimeter. So let's take the complete triangle OAB whose area we are calculating. And we know the area of a triangle is half into base into height. For this triangle, the base is AB, the chord AB, which we have just calculated as 12 root 3, and perpendicular is OD, which we have calculated as 6 centimeter. Let's solve it. We got area of the triangle AOB as 62.28 centimeter square. Now we can easily find the area of the segment, which is area of the sector minus area of the triangle. Let's put the value. We got our answer as 88.44 centimeters square. That is the answer of question number 7. Got it? So we have done with question number 7. Let's move to question number 8. Students, a important thing for you, check the description for the PDF of the complete formula list and also the link to the quiz. Use the formula list to brush up the concept before the exam and the quizzes to check your preparation before the exam. The link to both the formula list and the quizzes are given in the description. Check it out. So let's back to the lecture. A horse is tied to a peg at one corner of a square-shaped grass field of side 15 meter by mean of a 5 meter long rope. Find, two parts are given. First part, the area of that part of the field in which the horse can gaze. Second, the increase in the gazing area if the rope were 10 meter long instead of 5 meter. So a practical sort of question, an interesting question. Let's approach the question. In this question, a grass field is given which is square in shape and the dimension of the square shape field is given as 15 meter by 15 meter. A horse is also given which is tied to a peg and the peg is at the one of the corner of the grass field. And the length of the rope is given as 5 meter. The length of the rope is 5 meter. And in the first part, we have to calculate the area in which the horse can gaze. So this is the given part in the question. The horse is tied to the peg through the rope. If this rope is fully stretched, then the horse can move only in the circular direction. Or the maximum area in which the horse can graze is circular in nature. This path will be circular. This rope will act as a radius. So the area in which the horse can gaze, the outer boundary will be circular in nature. If we draw a circle with the center as the center of the peg, with the radius of 5 meter, which is the length of the rope, we can get a complete circle. And this shaded portion is looking like a sector. Basically, in this question, the area gazed by the horse is the sector of the circle. Basically, the question framer is asking us to calculate the area of the sector, which is equal to the area in which horse can gaze. These type of practical connection with the mathematics are very interesting. So let's approach it. We have simply converted the practical question into the mathematical diagram. Let's find the area of the sector. The radius, it is given as 5 meter and this angle is 90 degree. We are having a square field of dimension 15 meter by 15 meter. Basically this is a square and all the four angles of a square are 90 degree. This angle is equal to 90 degree. Theta, it is given as 90 degree. Radius, it is given as 5 meter. The area of the sector, it is theta upon 360 into pi r square. Let's put the value. So on solving, we got our answer as 19.625 meter square. This is the area in which the horse can gaze. One more alternative way in which you do not need to use the formula, just a different way to approach the question. If we take the complete circle, the area of this complete circle, this sector is the quadrant and quadrant is 1/4 of the area of the complete circle. The circle is divided into 4 quadrants and this quadrant is basically 1/4 of the area of the circle. So if you calculate the area of the circle, which is pi r square, you can divide pi r square by 4 to get the area of this sector. Just an alternative approach in which you do not need to use the formula of the sector. So we have done with the part 1. Let's move to part 2. In the part 2, the length of the rope has been increased from 5 meter to 10 meter and we have to calculate the additional area in which the horse will gaze. So if we increase the length of the rope, now the gazing area of the horse will increase. This is a new area and this is also a sector. Let's find the area of this sector. The theta is same as 90 degree. Only the radius has been changed from 5 meter to 10 meter. The new radius is 10 meter. Let's use the same formula, area of the sector. Let's put the value. We got the area of the sector as 78.5 meter square. That is the new gauging area. And in the question, we have to find the increase in the gauging area. The increase in gauging area will be the new gauging area minus previous gauging area. The new gauging area is 78.5 meter square. The previous one is 19.625 meter square. So we got 78.5 minus 19.625, which is 58.875 meter square. That is the answer of the question. So we have done with the question number 8. Let's move to question number 9. A brooch is made with silver wire in the form of a circle with diameter 35 mm. The wire is also used in making 5 diameters, which divides the circle into 10 equal sectors as shown in the figure. Find 2 parts are given. In the first part, the total length of the silver wire required. Second part, the area of each sector of the brooch. So this is the question. Let's observe the question. In the question, a brooch is given. A brooch is a decorative pin that is used with the clothing. So in this question, a brooch is given which is made out of a silver wire, and the brooch is circular in form with the diameter of 35 mm. So this brooch is circular and the diameter is given as 35 mm. Further, it is given the wire which is used to make this brooch is also used in making 5 diameter. 5 diameter means the wire has been cut into the 5 length, which is equal to 5 diameter. So these are the 5 diameter into the brooch, which is made from the same wire. Further, these 5 diameter are dividing the circle into 10 equal sectors. So these are the 10 sectors and all the 10 sectors are equal. So let's take down the first part in which we have to calculate the length of the silver wire. So the silver wire is used in the outer perimeter of the circle, that is the circumference, and this silver wire is used in the 5 diameter. So if we calculate the circumference or the perimeter of the circle and the length of the 5 diameters, then we can calculate the total length of the silver wire used. So firstly, let's calculate the circumference, which is 2 pi r, and 2r is the diameter, twice of radius is the diameter. So the circumference is pi times d. And diameter in the question is given as 35 mm. Let's use pi as 22 by 7. On solving, we got circumference as 110 mm. Further, we are having 5 diameter, the length of silver wire in the 5 diameter, and each diameter is 35 mm long. So the total length of the diameter will be 5 into 35, that is 175. So the total length of silver wire is equal to the circumference of the circle plus length of 5 diameters, which is 110 plus 175, which is 285 mm. So the answer of the first part is 285 mm, that is the length of silver wire required to make this brooch. Further, in the second part, we have to find the area of each sector of the brooch. Here in the question it is given we are having total 10 sectors and the area of all the 10 sectors are equal to each other. So we can calculate area of any of the one sector as all the sectors are equal to each other. Here we are having total 10 sectors and the total angle around the center of the circle it is 360 degree. The complete revolution of a circle it is 360 degree, and this 360 degree is divided into 10 parts. So a single angle will be equal to 360 degree upon 10, that is 36 degree. So each of these 10 angles are equal to 36 degree. We are having angle theta which is 36 degree and we also having the radius as 35 mm. We can find the area of the sector. The formula is theta upon 360 into pi r square. Let's put theta as 36, radius as 35 mm. On solving, we got area of the sector as 385 upon 4 mm square. That is the answer of the question. Got it? We can also use an alternative approach in which we do not have to use the area of the sector formula. In this alternative approach, we will find the area of the complete circle. And we are having total 10 sectors. Basically, the complete area of the circle is divided into 10 sectors. So area of each sector will be equal to area of the circle upon 10. Each sector is the 10th part of the complete area of the circle. The complete circle is divided into 10 sectors. So area of circle is pi r square and radius is 35 mm. Let's put the value. On solving, we got the same answer as 385 upon 4 mm square. So we can use any of the alternative approach to solve this question. And you should know all the approaches. These are really helpful in bit of the examination. So we have done with this question. Let's move to question number 10. Question number 10 is, an umbrella has 8 ribs which are equally spaced. Assuming the umbrella to be a flat circle of radius 45 cm, find the area between the two consecutive ribs of the umbrella. So this is the question. Let's observe the question. In the question, a umbrella is given which is having 8 ribs. These are the 8 ribs. These ribs are equally spaced. The top view of the umbrella is a circle with a radius of 45 cm. And we have to find the area between the two consecutive ribs. Let's take any of the two consecutive ribs. Let's take these two ribs. And we have to find the area between these two ribs. The shaded portion or the area between the two ribs is the sector. So basically in this question we have to find the area of this sector. The radius of the circle is given as 45 cm and this is the formula of area of the sector. The two inputs are required, the theta, that is the angle, and the radius. Radius is given, only the angle is missing. So let's find the angle. The complete revolution around the center of the circle, the angle is 360 degree. And we are having total 8 parts. This 360 degree is divided into 8 parts. So each angle will be equal to 360 upon 8. That is 45 degree. This angle theta is 45 degree. So let's apply the formula of area of the sector, that is theta upon 360 into pi r square. Let's put theta as 45 and radius as 45 cm. On solving, we got the answer as 795.5 cm square. That is the area between the two consecutive ribs of the umbrella. Got it? We have converted the practical scenario into the mathematical form. These type of questions are very interesting. An alternative approach also without the use of the formula of the sector. If we find the complete area of the circle with the radius as 45 cm, the area of the sector or the area between the two consecutive ribs is 1/8 of the complete area of the circle. So pi r square is the complete area of the circle and this area of the sector is pi r square upon 8. 1/8 of the complete area of the circle. We are having total 8 sectors. So this is one of the alternative approach. So we have done with the question number 10. So students, we have done with this lecture. Hope you have enjoyed the lecture. If so, like, subscribe and share this lecture. And do not forget to check out the PDF of the complete formula list and also the link to the various quizzes. The link is in the description. So best of luck for the exam you are preparing for. Bye for now and have a great day.